Much. So now, without further ado, I'm going to introduce Clay. I haven't met you in person yet, but I actually named you the artist. Clay Mayurk, Senior Vice President, Software Development here at Oracle. He runs cloud infrastructure and is a founding member of Oracle's Cloud Engineering Development Center in Seattle. He's tasked with building and deploying Oracle's next-generation cloud infrastructure. Prior to joining Oracle, he spent 4 years at Amazon and AWS Web Services. His experience has been focused on highly secure, reliable, performance-based systems. So please join me in welcoming Clay to the stage with a warm HITEC. Welcome.
I am not very prepared, so hopefully you guys have low expectations. Well, first I wanted to say I'm very glad that Oracle was able to have HITEC come and be with us today. I think, as I'm sure you've heard from other people, and you'll hear from me and you'll hear from others as well, diversity and inclusion is very important to Oracle. We believe that the strongest teams are made up of diverse groups of people, and we end up with the better ideas, and that really directly contributes to our overall innovation. And so we're very happy that we can have all of you here today, and I think we'll continue to do more together to make sure that we have the strongest teams, both in Oracle and in the industry, as well as making sure that translates into our overall innovation and the technology that we're building, both as a company and in the overall industry. So thank you all for coming, and thank you for having me here to speak with you today. So that's me on my wedding day. That's why I look so happy. But before that, I had a picture of myself in a hoodie, which people told me was not professional enough. And I told them that's true, but it was more comfortable. So I have a few minutes to talk to you all today. This is a very interesting group. Normally, I'm speaking to a bunch of people who are very deep into the technology space. So that you all understand, my name is Clay McGuirk. I run all of engineering for what Oracle calls Oracle Cloud Infrastructure. If you're not familiar with Oracle Cloud Infrastructure, you can think of it as Oracle's competitor to Amazon's AWS or Microsoft's Azure. So I'm usually talking about some very deep, low-level technical pieces about how we do some virtualization technology or some cool new innovation in storage. And given the audience, this is the first time I'm kind of trying to have a different topic for you today. So we'll see how it goes. The good thing is that based on how bad I am, I'll just go fast, and then we can do Q&A at the end. And then if you don't have any questions, we can all leave early. And they said we can all go to Six Flags. So I think if we just wrap this up in like the next 5 minutes, we can have some fun. So what I do want to talk to you today, and this is a kind of a theme that you'll hear throughout, not just today, but from Oracle in general, is we really believe in autonomy, and we're really bringing autonomy to the cloud. And so I know all of you are very familiar with the cloud. The cloud means many things. To some people, it means iCloud on their phone. To some people, it means buying an ERP system or an HCM system in the cloud. To some people, it means buying a bunch of virtual machines. And it's true of all of those things. And so what I'll be talking about is what do we see as big changes coming in the overall cloud space, and how we believe that all clouds need to be autonomous. And to explain that, I'll first talk about what I mean by autonomy, and then what are the things that we're doing here at Oracle to kind of make that vision a reality. Just so that you know, I think we're still very early days in the overall cloud transition, and I think we're even earlier in the autonomous cloud transition. And I'm very excited to see the possibilities of where this stuff is going to take us in our overall technology industry. So this is a statement that says that everything I say is lies, and that I'm not responsible for it. So good. I'm glad we agree. Artificial intelligence and machine learning have had a real resurgence, and I know there's some topics later today talking about what is AI doing to really change the overall business landscape. I'll be a little bit more focused here, but you guys see the things that are happening. I'm amazed by the technology. I like chess, and I see the things that the deep mind people can do with these new neural networks playing chess, and you see the advances that we're having with autonomous self-driving cars. What's really interesting about this technology is that it's more than just these really cool, super high-tech use cases. It also ends up being used in what is sometimes a little bit mundane applications. As I try to tell my team this as rarely as possible, but it's true. I work in the infrastructure space, and I often think of myself as a plumber. A lot of what I do and a lot of what my team does is we do this low-level, pipes and sockets that does the stuff that the cool people get to run on top. But I think the real value of artificial intelligence is not just in the super flashy stuff. It's about how do we bring that value to every aspect of the business. And so what we're doing at Oracle is bringing that artificial intelligence, bringing that machine learning into every layer of our cloud. And that's why we now talk about our cloud as an autonomous cloud. So what are some of the benefits of having that autonomy? In a very basic level, a lot of it comes down to you can offload these repetitive tasks. It's just, I see this as an extension of what the cloud has always been about. Suddenly, in the beginning, it was all about, hey, you don't have to provision a server, some automation does that for you. But what we're seeing now is, well, what if you didn't have to administer your database anymore? What if you could really have a truly self-driving database? What if you didn't have to worry about patching your operating system or doing security updates? What if the operating system did that for you? And what if the infrastructure could actually self-tune itself so that you didn't have to spend your time managing this low-level infrastructure? You could actually just run your application, and the infrastructure would adjust itself to you. And so in this area, I'm going to talk about 4 kind of pillars of things that we're doing at Oracle that make up our autonomous cloud, starting with autonomous database, which is very, very exciting, and I'll tell you more about that. Going on to what we now call autonomous Linux, the first truly autonomous operating system coming from Oracle. More near and dear to my heart is the autonomous infrastructure space, and talk about some of the innovations that we're doing there. And then last, I'll talk about what are some significant advancements we're making in the security space to really bring that autonomy to your overall security portfolio. So Larry Ellison announced Autonomous Database a couple of years ago, and I'll be honest, in the beginning, I didn't fully understand exactly where it was going to go, and it's been very exciting to me to see where the Autonomous Database has evolved over the past couple of years. I think the most exciting, the way I've been able to describe it to people is, I'm sure most of you have used databases, and even if it's been a while, you have many applications in your companies that run on top of relational databases. What's really cool is watching an autonomous database work, where you can actually install an application, you can drop all of the indexes, you run the application for a few hours, and behind the scenes, it actually goes and creates all of the indexes you need for the application. While it's doing that, it actually can patch itself, it upgrades itself, and it does that without downtime. The way in which we've been able to actually achieve this at Oracle is because we have taken that same commitment we've made to the past 40 years of relational database technology, and we've tackled the hard problems by putting that AI and ML directly into the database, and then spanning that work across the infrastructure layer such that we believe that you can actually build a database that's this good. This is very similar, I think, to what's going on in the industry across many levels, right? We still don't have the fully, completely self-driving car. I think most people now believe that's going to happen. But when it does happen, it's going to be a game changer for everyone. The same thing is true here. Oracle's the only company that's actually taking a step back and saying, hey, I don't think you should have to make a sacrifice. There's actually not an inherent trade-off here. You can get all the benefits of having a self-driving database, but still have all the flexibility you need to run your application. Another area we're making significant investments in is autonomous Linux. So I'm sure you all use operating systems. Linux is obviously the #1 server-side operating system in the world these days, and we live in an ever-increasing world of constant security threats. We have more software, it's more diverse software, there's more packages that customers are using, and all of those things, there's a possibility for having security incidents or security problems with that stuff. So then you find yourself in a position where, okay, I have these thousands of servers, and there's all these packages, and how do I keep track of them, and how do I patch it? Well, what we've done with autonomous Linux is to take the same idea that people have been shifting to, I think, for the past decade now with things like DevOps and things like continuous integration. Why can't your OS be constantly up to date? Why aren't we automatically patching this stuff? Well, there's a few reasons. Part of the reason is that people don't feel comfortable with it. But I find oftentimes comfort comes once you can see it working and it's proven over and over again. Part of the reason that we're able to do this at Oracle is we have this really amazing technology called K-Splice. And I know this sounds a little bit technical, but what I love about this technology is you can actually patch everything in the OS, whether it's in the user space binaries or whether it's in the actual kernel, without taking downtime. And so by investing in this K-Splice technology and then enabling it everywhere in our cloud, you can actually patch essentially all vulnerabilities without having to restart the host. Because traditionally, you had to go, if you want to patch, you have to do a restart of the operating system, and it's very invasive. You have to schedule it. We did some very, very hard work to enable the OS to patch itself. Then you combine that with a bunch of AI and machine learning on the side, where you're constantly understanding what packages are available, what threats are out there, and how do you give those updates to the right operating systems and the right hosts. And suddenly you have a significantly easier job maintaining a highly secure environment in the cloud. The other thing to understand that we're doing is we're not just bringing this only to our cloud, we're actually extending autonomous Linux into on-premise. So Oracle is a very large Linux provider to many, many companies, and with the power of the cloud and artificial intelligence, we're able to manage things centrally in the cloud, but you can actually run autonomous Linux on your premise, whether it's in your own data center, whether it's in a different cloud provider, whether it's on, on your laptop, let's say, and still get the benefits of having this real-time, constantly patched, secure OS without having to do reboots. So talking a bit more about autonomous infrastructure. So we're still very early days in the overall infrastructure space. People are still, you consume things, you get VMs, you get your block storage. The cloud has always promised that you would be able to get true flexibility. The idea was, hey, you want to be able to pay just for what you use. There's a lot of push into things like serverless, things like functions as a service, Lambda as an example, things like Kubernetes. Everyone wants to take more and more of the responsibility and shift it to the provider so that they can really focus on providing business value to themselves and their business. Well, we think that in that transition, something has been lost. Specifically, if you go and you write all of your applications to be done in a very specific way, if you write them all to run, for example, as Lambda functions, you do get the promise of the cloud. You get the elasticity and the pay for what you use. However, the vast majority of all computing is still done on top of computers, whether it's VMs or bare metal servers, running on top of block storage. And we just haven't taken the benefits of AI and ML into that space. And so what we're doing is, instead of making you choose up front a whole bunch of different VM shape sizes, whether you have, do I have to pick 8 cores or 16 cores? You shouldn't have to choose. What we've done is we're doing some very fundamental engineering such that you can dynamically resize the size of your instances. And then on top of that, we're actually putting an auto-tuning layer such that you can actually start out with an application. You don't have to pick the size of your infrastructure. Behind the scenes, we constantly analyze your workload, and we'll automatically scale your VMs up and down based on the performance you need, whether it's more RAM, whether it's more cores, whether it's fewer cores. And then, of course, as you do that, you only pay for what you use. The same thing we're doing in storage. So what we're launching, and this is actually coming out in the next 3 weeks, is a very elastic block storage solution such that you can have very low performance and low cost storage all the way up to extremely high performance storage, all online resizing, but more importantly, also self-tuning, such that you don't have to decide. You can pick a place, you start out, and if you're paying too much for the performance, great. And you're not using it, we'll just auto-scale you down. And if you're hitting application limits on this storage, will scale you up. The last area I want to talk to you about is security. So I think everyone here knows there's a lot of concern these days around security and data privacy. Part of that is because as we become ever more connected and as we collect more and more data, people become much more aware of the consequences of these security breaches. I don't think we have more data available today, and more companies have more data about all of us than has ever been available in the past. And so part of our job as a cloud provider is to make it simpler and easier for customers to secure their businesses on top of us. Now, people are taking different approaches to this. At Oracle, we're taking what we think is a very novel approach. We're very opinionated about this, and we think it's going to have a bunch of significant benefits for the people that run on top of our cloud infrastructure. So one thing we believe is that fundamentally, as a provider, we have to enable you to give us more responsibility for your overall security posture. And to do that, we have to actually give you the tools to give us that responsibility. The most common source of security problems in the cloud actually comes down to basic misconfiguration. In the cloud, we give you now have it's like a toolbox. You guys ever use one of those you ever go to a real mechanic shop and they have the 5-drawer thing with the 8,000 sockets? The cloud is like that, but imagine it was 50 times bigger, right? There's so many tools available in the cloud, and it's really great, except now you have a problem. Well, where did I put this? And did I configure that correctly? And am I using that tool properly? Well, what most cloud providers are doing right now is they're just saying, hey, that's your responsibility. What we're doing is we're taking a stronger approach. So we have this thing we call CloudGuard, and this is going to be rolling out over the next year. What CloudGuard does is it constantly watches your environment. And by default, it has a whole bunch of pre-configured rules. We obviously give complete control to you, the customer, but the main idea is it watches. So let's say that you go and you make a configuration change and you put a public bucket on the internet. Well, we're going to detect that. And that's about what most people do, and they tell you, hey, alert, did you know you did this thing? Why don't you fix it? The thing that we're doing is we're also going to have automatic remediation. So that you can turn this off if you don't feel comfortable with it. But the idea is when we detect these security problems, we have built-in remediation. So we can go and flip that stuff back to private. And to be fair, you guys all experience this today. I'm sure many of you use an email, webmail of some kind, and if suddenly you start logging into webmail from a different computer or a different IP address, they go, wait a second, I'm going to challenge you on that, and we'll do a 2-factor auth, this is a thing that we're all used to. Well, we have to take that same level of automation and autonomy and push that into everything we're doing at the business side. And so by actually enabling the ability for CloudGuard to actually not just detect and tell you about problems, but to actually fix them, it's a huge security benefit, because now you're not waiting for humans in the middle to go and get that alert and fix it. It can automatically fix itself. But we don't think that's enough. In addition to that, we also have a concept called a maximum security zone. And what we're doing there is we're creating a place where 100% of your entire application has to be at the maximum security settings. And you actually cannot mess it up, because we enforce that at the policy level. And so the way we're building this is that if you think about it, the combination of CloudGuard and maximum security zones is very powerful. Your most sensitive and secure data should go in a maximum security zone, and it's always protected. It's hard to put everything in there, because maybe you have some dev test workloads, maybe you have some things that need to be on the public internet and they can't live in that environment. That's okay. Put it around that and have CloudGuard watch it for you. And so by combining these two ideas, which are, combining these two ideas in the cloud, a place where you have your most secure stuff that you can't mess up, an entity that constantly watches and protects you and automatically fixes things, and then you combine those together behind the scenes with pervasive monitoring and analytics that tells you what's going on, it's an extremely powerful security posture that that I think is absolutely required to actually be secure in the coming years with the threats and the attacks that we're seeing across the board. And so And then, of course, you combine that with our autonomous Linux platform, which automatically patches the OS and detects new threats. It's a very, very powerful overall security story. And so the good thing is that we're going to get to go to Six Flags early, because I spoke quickly, and we're sufficiently good that not too many people took a nap while I was talking. We also recently launched an always free tier for Oracle Cloud. And what we do now is you can go and you can sign up. You get a free trial. You get a $300 free credits for the first month. But more important than that, we actually end up giving you 2 autonomous databases and 2 VMs free forever. And so what I encourage all of you to do, if you're at all interested in the cloud, is go and sign up, try it out, and see some of the technologies that I'm talking to you about here today. You're going to see a lot more from us here at Oracle. I'm very excited by the work that Oracle's doing. I've been in the cloud industry for probably 10 years now, and one of the things I've always really respected and appreciated about Oracle is that Oracle is a technology company that's not afraid of tackling hard problems. When I worked at other cloud companies, we spent a lot of time finding easy ways to solve easy problems. Oracle often takes the hard job of saying, hey, we're going to tackle really deep engineering problems, things like autonomous database, and use that to really solve fundamental problems our customers are having. It takes us a while. Sometimes it takes many years for that stuff to actually come to fruition. But when it does come to fruition, the results are orders of magnitude better than you would imagine. So with that, now we're going to make up for my bad timing with your questions. The good thing is we can talk about whatever you want. I also love TV shows. We can talk about race cars. I like those. We can talk about general industry trends, computers. Anyway, or, as I said, we can stop and then Six Flags.
Thank you very much for sharing this information. I appreciate that. As you said, this seems to be a pretty novel idea. So actually I'm from Fannie Mae. So we are also into cloud journey. I don't want to go into specifics of which cloud provider and all that. But the basic thing is, even we are struggling with what we have today. And this is a novel idea. How are you going to scale? Because people will be more skeptical, going into cloud, what we have today. But this is more like, fully automated, AI. So how is the market reacting? What is your initial thoughts on that?
Sure. I think actually this is trying to solve exactly the problems that you're experiencing today. I believe that technology is too complicated, right? I mean, I'll be very honest. If installing an Oracle database is not for the faint of heart, and then trying to tune it is not an easy job. Go sign up for a free trial. Within 2 minutes, you have a completely running autonomous Oracle database that self-tunes itself. That's making it much, much easier for businesses to actually move to the cloud. Now, obviously, there's skepticism and there's caution, right? Because all new technology, of course, comes with a bunch of new bugs, as we've all seen from our Mac updates recently. That was a joke, guys. It was a good joke, too. It was amazing. It's the best joke. I do think that these things do take time for people to adopt them. However, I think this is the reason people are moving to the cloud is because they are expecting more. They don't just want the same as on-prem. They don't just want a bag of bolts they get to put together. They really want the cloud provider to take on more responsibility and to deliver higher value so they can focus on the differentiation they do in their business. And so I think this is novel. It's kind of the next step, but I see this also as a continuation of what we've been doing in the cloud for many years. Specifically about autonomous database, tons of existing Oracle customers, as well as new customers who aren't traditional Oracle customers, are very happy with it because it makes it very easy for them to set up a new data warehouse or a new transaction processing system. I think part of the reason why a lot of new apps were being built on things like Cassandra or DynamoDB or React or Voldemort or any of these NoSQL stores is because they had a simpler model. but that actually put more responsibility back on the customer. What we're saying is we can actually do better. Yes, we made it too complicated. We can simplify it. But we can also give you the true power of a relational database with all of our query capability and as well as the transactionality, et cetera. So I think customers are being very receptive to this. But like any technology decision, there's a rational business case and an on-ramp you have to take.
Thanks. Question on security. There have been numerous cases recently where bad actors have exfiltrated massive amounts of data. I'm not going to name any firms, but we know it's happened. In addition to what you said about securing the storage buckets, right, making sure if they're not supposed to be publicly exposed, they're not. How are you thinking about those things that are more nuanced, where data should be available, but maybe someone's exfiltrating terabytes of it and that wasn't intended? How are you guys approaching that problem?
Great question. So this is the way we're thinking about it, and this is the kind of stuff that, truthfully, only a cloud provider can do. So I didn't go into the full detail of CloudGuard, but what we're looking at is you have to build fundamental remediation actions into the underlying services. So for example, take object storage. Obviously, you can say this is public or it's private, but one of the things we're also doing is we're adding the throttling capability. So what you can do is you can say, hey, maybe it's in the middle. I don't know if this is bad, but it seems suspicious. I'm going to slow it down. Right? And so now you have a speed dial where suddenly, okay, someone starts reading the data, let's slow it down, and let's also notify somebody so the application's not broken, right? But at the same time, they're not able to copy the terabyte in a minute. It should take them a couple of hours. And so it's the same thing around quarantining, right? Because as a cloud provider, you have access to the full, virtual network. If you have a host that you think has been compromised, one of the things you can do is you can say, well, let me quarantine the network around it so it's still running. Maybe you want that later for forensics, or maybe we got it wrong and you're going to want to turn it back on really quickly. But let me just prevent it from accessing anything else outside of itself by removing its network access. Those are things that you can only do when you have the full stack as the cloud. And it's also, to be able to make those decisions, you need telemetry data from all of the different sources. You need to understand what's going on in the OS itself. You need to understand what's going on at the network layer, at the storage layer. And so absolutely all of those kind of gray areas have to be built in. And those capabilities are the things you have to add to have confidence in kind of taking automated remediation, because it can't just be 1 or 0. If you do that, then people are going to want a judgment person in there in the middle. Instead, okay, well, let's start with notification. Okay, now let's start with maybe you challenge some more. Maybe you slow it down, you can quarantine, and then at the most extreme, you can turn it off. And you have all those different layers of remediation, and you do that for every different type of system you have, whether it's a storage system, whether it's a compute system, whether it's a security system, right? At the extreme, you can revoke a user's credentials and they no longer can use, or maybe you just slow down their actions, or maybe you just challenge them more. All of those are very possible, and you just have to build them in, the individual actions into the underlying system, and then you create this configuration layer, which is CloudGuard, to configure them and then to actually choose which actions to take.
Clay, quick question. The top talent to make the cloud happen is not very abundant. So I wonder, how are you dealing with that? And the second question is, how is the Hispanic community measuring up to the skills that you need to make it happen?
So I agree with you that, well, I think we have to differentiate between talent and skills. I know it sounds a little pedantic, but I do think there's a difference between capability and then current knowledge. I think in the cloud, because it's a relatively new technology, and it's not, how new is it? It's been around for a while, but it's still, a newer technology, especially if you talk about things like AI and ML, it's even newer still. I think that typically is a skills gap. It's not a capability gap. Right? And so the things that you do, I think, to fix skills gap and capability gap are different. One of the things that we're doing within Oracle Cloud Infrastructure is, we're headquartered in Seattle, and in large part that's because that's where most of the cloud companies came from. That's where I came from. We had the leadership there. And one of the changes we've made over the past 6 months or so is, prior we had hired lots of very senior people who had a lot of experience. But that's not a healthy organization. And so one of the things that we've actually been doing over the past 6 months, and we're hiring throughout the rest of this year and in next year, et cetera, is we're focusing on more junior roles. We're spending a lot more time on internships from colleges and expanding our college selections. We're spending more time on people who are coming straight out of college, and we're also spending a lot more time getting more people who have fewer years of experience. And that has many benefits for us. One is you actually end up with a more diverse, it's easier to get a diverse workforce before it's been kind of filtered through the industry so much. You can get direct access to that. Part of that is you end up with a healthier organization overall, where you have people that are learning, they're excited to be learning, they're doing these tasks, and they're growing. Versus if you have a very senior, top-heavy organization, it can become kind of stagnant sometimes. And then it's also forcing us to spend more time around how do we actually, when you have to teach other people, you end up with actual better processes, right? Some people see it as a tax. If you have more junior people, you think, oh, I have to train them now. Yeah, it's actually really good, though, to get your processes in order, to have explicit training programs within the organization, because then it actually makes even the more senior people better, right? Pilots for all airplanes use checklists. It doesn't mean they're not good pilots. It just means that they take what they're doing very seriously. And so those are all some significant changes that we're making within Oracle Cloud Infrastructure to make this better. We're hiring a lot of people, and it's been very encouraging so far, and I think it will continue to be. In terms of specifically around, say the Hispanic community, part of what we're trying to do is go after areas where, so for example, recruiting from specific colleges where we can get access to those people. We have to do a better job, I think, of communicating Oracle. We're still very early days within Oracle Cloud Infrastructure. We've only been around for a few years. Communicating our value proposition, exciting people to want to come work for us, and then making sure we have the right opportunities. We're developing a whole new internship program where it's a 2-year program where you come for a year and then you come back for another year and you get to a different team. And we're actually doing something very similar for our college onboarding program where previously we had kind of just put people in a specific spot. And what we're trying to do now is create a program where you get a 2-year rotation. You join, you work on it with a team for a year, and then you get the opportunity to go to a different team to learn a different area. To really encourage new blood coming into the groups, and then encouraging cross-pollination and learning within the overall team. So those are a few of the things we're doing.
Thank you.
Hey, Clay, thanks for taking time out of your hectic schedule. Actually, maybe I won't ask you my question so we can go to Six Flags now. But, how does can you share experience where, maybe on the operational side, some of the stuff we're dealing with is occasionally get some bad code or maybe inefficient code gets introduced to the platform, and you get some malformed SQL will generate a whole bunch of unexpected load on the platform that floods everything out, and ultimately, in our case, we've had some outages. On the autonomous side, how does that react? Would it act like a governor and kill it, or would it start automatically adding a bunch of resources to address maybe some inefficient code that needs to go back to the development team? Can you share some experiences along those lines?
Sure. Well, the good thing is that it actually ends up doing both of those things. So, and sometimes that can be bad because it kind of masks the underlying problem. But in general, the way you handle that is that you can do notifications about. So let's say that you deploy some bad SQL, and now let's talk about bad SQL for a second. One of the things oftentimes that SQL is bad is because it's not using the right indexes, or the actual underlying data structure is not matching the query pattern. Well, what Autonomous Database will do is it will actually change the underlying data layout to match that new query pattern. And so in that sense, there isn't necessarily bad SQL anymore. It just wasn't optimized for that layout. Well, let's just change the layout, right? And so by adding indices and changing data layout, you can actually serve those queries automatically behind the scenes. So that's one thing. But obviously there's always going to be use cases where if you go from reading the row 1 time a second to 5,000 times a second, that's going to create more load. And so what happens there is that you then say, cool, I'm going to add more cores, and I'll add more memory, and I'll scale up this database to be able to meet that load. So what you then can do is this is all integrated into, for example, our notification system. You can then get a notification saying, hey, your overall CPU utilization went from X to Y. And then you can go, okay, well, that's the kind of thing you would put on your operational dashboard. Look, okay, we just deployed some stuff. Maybe we need to roll that back. Or maybe, that's really important right now and we'll pay it. And we just need to optimize it. And we can deploy that in the next few days or next week. So those are the kind of actions that will automatically be taken. It doesn't completely alleviate the need because obviously there's still some responsibility you have to decide. Do you want to be that inefficient or do you want to optimize? But by having the autonomous database be able to automatically change the indexing patterns and also automatically being able to scale itself up. And the cool thing about, when I say scale up, it's very easy to talk about this stuff. This actually happens real time and online. It doesn't take the database down, wait 10 minutes and scale it up. If you do that, that's just guaranteeing an outage. This is saying, hey, no, I can actually scale the cores while it's still running. But then what's nice is that when you fix it, you can actually just scale the cores back down. You're not stuck at this larger capacity commit. And there's no big outage or anything you have to take to do that adjustment. Okay.
Hi, I have a question. I work as a security analyst at FireEye, and I have a question regarding the dynamic storage. You mentioned that that the storage increases and it also goes down as you don't need it anymore. So how does that actually work? Like, let's say you were to delete, we know when we delete files from traditional storage, it just removes the pointer to that file and the file's still there and you can recover it from the slack space. So when you shrink a cloud storage, what happens to the file? Are you removing it completely? And forensically, if there's an incident and I want to investigate or maybe pull that file forensically, how can I do that when the storage is shrinking dynamically?
Sure. Well, first, great question. You're highlighting some, I should have done a better job of explaining myself. So one thing that we're really focused on right now is assume you have a fixed size storage volume. You can dynamically change performance. Okay, so you can start with low performance, move up to high, all of that, and that doesn't address, that won't affect the thing you're talking about. We do support automatically increasing the size of storage, but we do not automatically decrease. At the block volume layer, you can't tell which blocks are being used from that perspective. Now, at the database layer, because we actually have full understanding of what's going on in the database, right? Because as people delete things and as things get pruned, there we can actually dynamically add and shrink storage. So at the block volume layer, we only support increasing. At the database layer, it will dynamically scale up and down. Does that make sense?
Yeah, that makes sense.
Okay, I'll try to do a better job next time. Good catch. Okay. Oh.
So one question, Jose Mingarens from Fannie Mae. In a new world where everything is as code, are you guys also, is Oracle also investing on native kind of tools for build, deploy, and as well as APIs for the app teams and anybody's building business applications to interact with your cloud?
Of course, so that's a big kind of question area, so I'll try to make sure in terms of kind of what are we doing around the build and deploy stuff. So we do have, for example, a fully integrated CI and CD service coming out in next calendar year. So we will have an option for you to store, your code repository. I find that most customers, especially our customers, they either want to just use GitHub or they want to use, something they have on-prem, et cetera. So code repository will also have, but it's not the dominant use case. Continuous integration is very important. And then I think deployment is actually a thing that's very closely coupled to the overall cloud platform. And that's where we have to do a really good job of making sure you can do, blue-green deployments and how do you do rollbacks and that integrated into the infrastructure, whether you're deploying VMs, whether you're deploying functions on our function service, or whether you're deploying containers into Kubernetes, you need a unified deployment system that supports that. So we're building that, and that'll be available next year. In terms of more application level stuff, Oracle's doing some very interesting things around our integration cloud service and also this thing we call Visual Builder Cloud Service. So a lot of our application customers don't want to have to go in and do everything from scratch. And if you go back 10 years, the best we could do is we'd say, hey, here's some SOA CS and here's some Java Cloud Service and use a WebLogic container and you can write things from scratch. What a lot of our customers really want to do is they go, hey, I just bought HCM from you. I want to build a custom workflow or a different step in there. Why can't I drag and drop some visual widgets, wire this stuff together with some REST endpoints. Well, that's exactly what Visual Builder Cloud Service does. That's available today, and we're adding a bunch of enhancements on that. And so what I find is that most of our application level customers, whether they're Fusion applications or things like NetSuite, et cetera, they end up consuming higher level constructs, Visual Builder, Integration Cloud Service. And then people who are kind of low level infrastructure style developers, they're more concerned with, well, how do I do a Git check-in? How do I do my Jenkins build? And then how do I get this deployed? And so we're doing both of those. They end up looking quite different because the customer, the persona is very different. But we're doing both of those. You're going to tell me when I have to get off, right? Okay.
So,
Because my timer says 0, and I was like, go ahead.
So quick question. What is the strategy of on-prem applications like PeopleSoft and eBusiness Suite moving to this autonomous infrastructure cloud?
Yeah, so it's a great question. So first I'll talk about what's our overall strategy with things like eBusiness Suite, PeopleSoft, et cetera, and then specifically with respect to autonomous database. So there are a lot of packaged apps customers out there. Obviously, in an Oracle ideal world, we'd like all of those customers to upgrade to Fusion applications. However, it turns out many of those customers don't want to do that, or they have significant customizations that make that very hard, and it's going to be a long process. I think in the long term, that's where everything goes. But long term could be 5 years, it could be 20 years. Put that aside. We have a lot of customers that really enjoy taking things like PeopleSoft and eBusiness Suite and running it on top of Oracle Cloud Infrastructure. And ignore Autonomous Database for a second. They use Exadata Cloud Service or our database service. We have easy migration tools to move those on top of us. It becomes very easy for customers to do things like test new eBusiness Suite upgrades and patch things. You can do snap clones. There's a lot of automation put into the system to make that stuff easy. But even more is, hey, so we got this cool new Autonomous Database. Are we going to make sure that works for things like eBusiness Suite? So the good thing is that those application teams are actually working to certify those applications on Autonomous Database. So the idea there is that even if you don't want to upgrade all the way to SaaS, you can actually move eBusiness Suite and run it, say, in our cloud, and then use Autonomous Database as the underlying database for eBusiness Suite or PeopleSoft, et cetera. Now, I will be, one caveat there is that that's not going to be backported to the 11 jillion old versions of those apps, right? And so what that means is that, great, if you want to come and upgrade eBusiness Suite to the latest version, that will work with Autonomous Database. I'm not going to be able to backport Autonomous Database support to the 9-year-old version of EBS that someone may be. So we are working on that, and for some customers that will be very compelling, and in some customers who are attached to a specific version and don't want to upgrade, that's going to be more difficult. But we still support those customers on our cloud via our database service, Exadata service, directly on infrastructure. Okay.
Hi, I'm Lydia Santos with UPS. I'm here. Thank you for the valuable information. It's impressive to see how you're using AI to manage your infrastructure. My question is around some of that analytics, that valuable analytics. What is your strategy in terms of making that available to organizations and in particular software development organizations that are running their applications in your cloud environment?
To make sure I understand, when you say you mean the actual analytical capability, or do you mean the actual data itself? I'm
talking about more of the data, but obviously the analytics capabilities are of interest as well.
Sure. So, part of what we're doing is that, so we have a lot of internal AI and ML services today. We're working very quickly to productize those. So you'll see a lot of services coming out. For example, we have a data science service, there's a data catalog, there's a serverless Spark service. All those things are actually in limited availability now, and they'll be out in the next few months. And that enables customers to do their own AI and ML work on top of our platform much easier. In terms of how do you expose this data, part of that comes through, we have a pervasive logging and telemetry systems. And so like everything that we're talking about here in CloudGuard, the general idea is all of the data that we collect should be in a form that's not just that we can analyze, it actually gets stored and you can analyze it yourself. So, for example, we have an audit system that for every API call that's made, whether regardless of service, it's automatically logged and it records who made the call, when it happened, was it successful or not, from all that kind of information. That's durably stored for you automatically. So CloudGuard just sits on top of that. Well, you have real-time telemetry data coming out, your CPU utilization, all these network metrics. That's also stored durably. And so the idea here is that, yes, we're using those sources, but we automatically collect a bunch of data. That's stored, you can access it yourself. And then you can also supply custom logs and custom telemetry that we'll store for you, and then we'll take that same data and plug that into CloudGuard as well. So the general idea is you build these things in layers such that if you want to opt into the cool analytical capability, the automatic analytics that we use, great. If not, we have to, as a cloud provider, also take that data and make it very visible and easy for you to use. And that's all done via standard services and APIs that just happen automatically. Does that make sense? Okay. Well, I now have 7 seconds left. I really appreciate you guys coming out and listening to me talk. It has been very fun. Hopefully you guys have a fun rest of the day. Apparently no Six Flags. Thank you very much.